Now today we are going to discuss the map W equal to 1 by Z. So W equal to, when we consider the map W equal to 1 by Z, separating the variables, we can write W is written as U plus IV and Z as X plus IY. So we can write this as U plus IV equal to 1 by X plus IY, and to separate this real and imaginary part, we multiply with the conjugate of the denominator. So 1 by X plus IY into X minus IY divided by X plus IY, and this is equal to X minus IY divided by X square plus Y square. So we can write U equal to X divided by X square plus Y square and V equal to minus Y by X square plus Y square. And sometimes it will be convenient for us to write X and Y in terms of U and V. That is, you can write this map as Z is equal to 1 by W. So if you want to separate for X and Y, that is, this is X plus IY equal to 1 by U plus IV. So if we proceed as we have done here, you can write X is equal to U divided by U square plus V square and Y equal to minus V divided by U square plus V square. So keeping this in mind, we are going to discuss the image of lines parallel to coordinate axis first. So we consider the Z plane and the W plane and lines parallel to coordinate axis. So at first let us take X is equal to K. So XY plane, this is the UV plane, and we consider X is equal to K. So we know our expression for X in this map is X is equal to U by U square plus V square. So X is U by U square plus V square. So X is equal to K will be mapped to U by U square plus V square equal to K. So we are directly getting a relation between U and V. U square plus V square minus KU equal to 0. And this represents a circle in UV plane. If you have a second degree expression, to identify the conic section represented by that expression, you just look for the second degree terms. If both one is a second degree term and the other is first degree, that will represent a parabola. If there are two second degree expressions, here we have U square and V square, we look for the coefficient of U square and V square. If the coefficients are the same, for example 3U square plus 3V square, here it is 1 and 1. If the coefficients are the same, then that will represent a circle. If the coefficients are different, for example 2U square plus 3V square, and of the same sign, it will represent a ellipse. And if the coefficients of the second degree terms are different in sign, that will represent a hyperbola. So here the coefficient of both U square and V square is 1. This will represent a circle and it has no constant term. So that means the circle passes through the origin, right? And see, here we have V square. You can write completing the square as some U minus A the whole square. You can combine these two terms. to complete the square plus v square equal to some r square. You can change this into this form. That means the center is A0. The center lies on the b equal to 0. That means the center lies on the u axis and it passes through the origin. So the image of x is equal to k will be circles that passes through the origin and with center on the u axis. So as the value of k changes, the size and position of the circle may change, but it will pass through the origin and its center will be on the u-axis. So that is the image of x is equal to k. Now let us find the image of y is equal to c. So to find the image of y equal to c, we know y is written as minus v divided by u square plus v square. So y equal to c implies minus v divided by u square plus v square equal to c. That is u square plus v square plus cv equal to 0. As we mentioned before, the coefficient of u square and v square are the same. This represents a circle. Now constant term, the circle passes through the origin and it can be written as u square plus v minus b the whole square equal to r square. That is completing the square here so that the center is 0, b, a point on the imaginary axis. U equal to 0, that means imaginary axis. So lines parallel to the horizontal axis will be mapped to circles that passes through the origin and center on the vertical axis. So image of y is equal to c will be circles that pass through the center and with image the pass through the origin and with center on the imaginary axis v equal to 0. So that is the image of y is equal to c, and we can combine these two information to find the image of a rectangular region. So if you take a rectangular region a less than x less than b, or a strip, let us find the image of a strip a less than x less than b. So we know the bounding curves x is equal to a is mapped to u by u square plus v square equal to a. So x greater than a means u by u square plus v square is greater than a, or you may write this as a into u square plus v square minus v less than 0. Taking this to the right side, it becomes a into u square plus v square. Taking this to the other side, this should be minus u. That should be less than 0. And a into u square plus v square minus u equal to 0 represents a circle. So less than 0 will represent the interior of the circle a into u square plus v square minus u equal to 0. If it were greater than 0, that will represent the exterior of the circle. So again, this is a circle with center. You can write this as a into u minus some k the whole square plus av square equal to 0. So this is a circle with center on the horizontal axis that we have already seen as the first case. Line x is equal to a will be mapped to a circle with center on the horizontal axis. So we have x is equal to a, in the xy plane, x is equal to a and x is equal to b, and we are finding the image of this infinite string. So at first we found the image of x greater than a. So x greater than a is mapped into the interior of a circle. So x greater than a, it's a circle that passes through the center and it is mapped to the interior of this circle. Now if you take x less than b, what you will get is b into u square plus v square minus u greater than 0. That is u divided by u square plus v square less than b, that is x. So b into u square plus v square minus u greater than 0. So we have another circle that passes through the origin and center in the center on the horizontal axis because v equal to 0, and greater than 0 means we map to the exterior of the circle. So interior of the circle and exterior of the circle, the image will be this. So we have this as the image of the infinite string. Likewise, you can find the image of the infinite strip c less than y less than b. So that will be a similar region but with center on the vertical axis. And for this map w equal to 1 by z, circles will be mapped to circles or straight line. Circles goes to circles or straight lines. And the straight lines will pass through the origin. So let us see the map w equal to 1 by z. As we have seen before, x can be written as u by u square plus v square and y can be written as minus v divided by u square plus v square. Now let us take a circle in the z plane. What we say is a circle in z plane will be mapped to either a circle or a straight line in z plane. So if you take this, a circle in z plane can be written as x square. If you make that coefficient as 1, you can write this as x square plus y square plus 2gx plus 2fy plus c equal to 0. The general equation of a circle in xy plane. So we are going to show that this will be mapped to a circle in UV plane. So to get the image, we replace x by u square plus v square. So we get u square by u square plus v square, the whole square, plus y square is v square by u square plus v square, the whole square, plus 2g into u by u square plus v square plus 2f into minus v by u square plus v square plus c equal to 0. Now if you look at the first two terms, it is u square plus v square divided by u square plus v square, the whole square. Right? So you may cancel one u square plus v square and write this expression as 1 by u square plus v square plus 2gu by u square plus v square minus 2fv divided by u square plus v square plus c into u square plus v square equal to 0. Sorry. plus C equal to 0. So if you multiply, see, u square plus v square is the common denominator, multiply throughout by u square plus v square, you can change this into an expression 1 plus 2gu minus 2fb plus c into u square plus v square equal to 0. See this, we multiply by u square plus v square, 1 plus 2gu minus 2fb plus c into u square plus v square equal to 0. And see, this is an expression in u and v, and it has two second degree terms, u square and v square, whose coefficients are same, c. So this will represent a circle in UV plane. So a circle in XY plane is mapped to a circle in UV plane, and suppose C equal to 0, this becomes 1 plus 2gu minus 2fb equal to 0, and this will be a straight line in UV plane. So a circle in UV plane is mapped to a circle in UV plane if C is not equal to 0. And see what happens when C equal to 0. When C equal to 0, this circle will pass through origin. Right, now constant term. So this will be a circle that passes through the origin. So you can say circle that passes through the origin will be mapped to straight lines, and circles that does not pass through the origin will be mapped to circles itself. So these are the things I wanted to discuss in the map W equal to 1 by Z.